Welcome, tech enthusiasts, to The Explainer. Right off the bat, we're looking at something absolutely fascinating today. You know, when we think about large language models, we usually just picture them as these basic input-output machines. But what if we started treating an AI agent more like a living organism? Think about it. An organism needs a working brain, it needs a reliable memory, and it needs a highly responsive nervous system to actually interact with its environment. Now, our challenge, and honestly it's a massive one in the developer world, is figuring out exactly how to build these stable, long-running LLM agents that don't just, well, collapse under their own weight. So today, we're decoding the truly elegant architecture of AgentScope to see how they pull this off.
And that brings us to our central question. If you've ever built AI apps, you know this pain all too well. Seriously, how do agents remember forever without crashing? We've all been there, right? You're building this complex AI application, the conversation gets super deep, tools are firing left and right, and then boom, you hit the dreaded token limit. Your whole app just crashes, or your users are left staring at those clunky, spinning waiting screens, while the backend completely chokes on massive text payloads. And yeah, usually it takes your OpenAI credits down with it. It's literally the ultimate bottleneck of modern AI development.
Okay, let's dive into this. Here is our roadmap for today. First, the agent memory bottleneck. Second, compacting and offloading context. Third, messages, the complete turn. Fourth, events, the real-time stream. And finally, reconstructing the conversation.
Section 1. The agent memory bottleneck.
To really wrap our heads around this memory bottleneck, we have to look at the agent's working brain, which is what AgentScope calls context. Now, this isn't just the prompt a user types in, it's every single message, every internal tool call, and all those insanely bulky JSON tool results that the LLM has to look at on every single reasoning step. It's incredibly powerful for sure, but man, it is highly prone to getting overwhelmed. Because as conversations naturally grow, this raw context expands so rapidly that it eventually just blows right past the absolute window limit of the underlying model. If it's left unmanaged, the agent's brain essentially runs out of space.
Section 2. Compacting and offloading context.
So how do we stop the agent from crashing? Well, AgentScope acts as this automatic, invisible memory manager. It runs a completely transparent 5-step lifecycle right before every single reasoning step. First up, it counts the total tokens of everything. We're talking prompts, context, tool schemas, the whole shebang. Second, it checks that total against the threshold you've configured. If it's too high, it triggers step 3, which is splitting the older messages away from the most recent ones. Now, step 4 is where the real magic happens. It actually calls the model to generate a structured summary of those older messages. Finally, step 5, it updates the state, replacing all that bloated history with a tight, clean summary. And the best part? The agent just keeps working, entirely uninterrupted.
Now, you might be wondering about that threshold. The absolute maximum trigger ratio you can set for compression is 0.9. Why not a full 1.0, right? Well, it's actually a remarkably clever dual-track design. Think about it. If you let the context hit 100% of the token limit, you wouldn't have any room left to ask the model to summarize it. So by capping the trigger at 90%, AgentScope guarantees that exactly 10% of the window is securely reserved specifically for that compression call itself. It's like reserving brain space just to organize your own thoughts.
But hold on. What happens to all those older messages and those massive tool results that got dropped or truncated? They aren't just deleted. No way. They're what we call offloaded. AgentScope uses an offloader protocol to persist all this dropped content externally. Out of the box, it uses LocalWorkspace, which safely and securely isolates each agent run into its own folder by session ID. And because it's built on a structural protocol, you can easily plug in custom offloaders. That means you can push this overflow memory directly to your databases or vector stores. So later on, if the agent suddenly realizes it needs a forgotten detail, it can literally just use file tools to read or grep that exact data back into its working memory.
Section 3. Messages. The complete turn.
Okay, so if context is the working brain, we can think of messages as the permanent spoken thoughts of our agent organism. A message is the complete, permanent record of a conversational turn. It is absolutely critical to understand that a single assistant message represents a fully completed reply cycle. The agent might have spent cycles reasoning, acting, gathering results, but it all culminates in this one persistent message object. And that object is strictly used for storage and formal communication between agents.
Now, what's really interesting is that these messages aren't just flat text strings.
They're actually constructed from heavily typed content blocks, which enforces strict role constraints. For instance, a text block can be used by any role, but a thinking block, which represents chain-of-thought reasoning, or a ToolCallBlock, those are strictly reserved for the assistant role. And take a look at the hint block. This is a fascinating little feature. It's used for out-of-band triggers. This allows background scheduled tasks to literally inject payload silently right into the conversation, almost like a subconscious whisper to the agent.
Section 4. Events. The real-time stream.
So, if messages are the finalized thoughts, events are the agent's nervous system. Let's draw a stark line in the sand here. Messages are completed conversation turns. They're heavy, permanent context storage that contains the complete state. Events, on the other hand, are incremental progress updates. They're incredibly fluid, real-time streaming fragments of very lightweight data. While messages are sitting safely back in memory, events are out there firing in real time, literally driving your responsive user interfaces.
And every single piece of streaming content in AgentScope follows this universal lifecycle pattern. It kicks off with a start event, which is immediately followed by a rapid-fire sequence of delta events carrying these tiny micro-moments of text or data, and then it wraps up with an end event. But the essential glue holding all of these rapid firings together is a shared reply ID. That ID links every single micro-event straight back to the ultimate message it's actively helping to build. Let's see how this builds out into specific, low-level event categories. You've got lifecycle events, like reply start event, managing the big picture. You have data streaming events, handling chunked base64 arrivals. Then, we have human-in-the-loop events, like require user confirm event. Imagine your agent suddenly decides it wants to execute a credit card charge. This event beautifully pauses the whole execution, just waiting for the user to say OK. And finally, one-shot events, like the hint block event, deliver a full payload in one go, rather than streaming it, simply because the data is already known right up front.
Section 5. Reconstructing the conversation. All right. We need to tie this whole nervous system of events back to the permanent thoughts of our messages. Because of AgentScope's brilliant architecture, exactly one complete perfect assistant message is absolutely guaranteed to be recoverable from its sequence of streamed events. That's a huge promise. They are quite simply two different views of the exact same data.
So the crucial piece of magic here is how this recovery actually happens, and it's all through a method called append_event. As your events are streaming into the front end over a WebSocket, this method applies them incrementally to reconstruct the exact message state. A TextBlock start event creates an empty block. TextBlock delta events concatenate the text together, and a require user confirm event instantly updates the UI state to asking. This is a real game changer for deployment. If your user's network connection drops while the agent is typing, you don't lose the thought process at all. You literally just replay the event sequence from a checkpoint, and boom, the front end is perfectly restored.
By securely offloading massive context behind the scenes and perfectly separating permanent messages from real-time streaming events, AgentScope really provides an incredibly elegant abstraction for developers. So we're going to leave you with this final provocative thought. With infinite memory effortlessly managed behind the scenes and real-time streams beautifully tamed for your UIs, what complex, human-in-the-loop, resilient agent will you build next? Thanks so much for joining us on this explainer, and we'll see you on the next deep dive.